Okay, let's dive right into this explainer. Today, we're going to completely change how you look at the mathematics Cambridge exam strategy. I want you to imagine you're a sculptor, and you're standing in front of this massive, intimidating block of mathematical data. Your job isn't to smash it with a hammer. Your job is to carefully chip away all the irrelevant stuff to reveal the perfect, pristine answer hiding inside.
Look at this number on the screen, 15. What's absolutely staggering about this number is the sheer weight it carries for your final grade. Finding the square roots of a complex number accounts for approximately 15% of the total marks in Paper 2 of the Mathematics 9709 syllabus. 15%! That is huge. This isn't just some trivial question you can afford to skip over. It's literally a foundational pillar of your exam. But here's the thing. When we look at how candidates tackle this massive block of marble, we consistently see two types of students completely failing to reach their potential. First, you've got Alex. Alex overloads every single answer with raw mathematical facts. They spot a complex number question and just panic dump every formula they've ever memorized onto the page. There's no analysis, no structure, just a chaotic, unreadable block of ink. And then we have Sam. Sam is always rushing. Sam has their eye glued to the clock, completely misses the specific command word requirements, skips the essential algebraic steps, and just jumps straight to a final answer. Both Alex and Sam are losing massive, massive marks. And it's not because they don't know the math. It's because they simply don't know how to sculpt the answer. Well, today, we're going to fix that.
All right, Section 1, the Sculptor's Procedural Framework. Let's look at the actual method. And hey, before we get into the nitty-gritty, make sure to subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations.
So here's the reality check. Cambridge doesn't just want the right answer. They demand to see exactly, step by step, how you arrived there. Let's break down the actual mathematical sequence you need to score full marks. Think of it as a four-step pipeline. First up, identify key elements. You have to decode the command word. Is it asking you to show that, find, or calculate? You extract the exact values given in the prompt. Second, apply relevant principles. If we're finding the square root of a complex number, say a plus ib, your guiding principle is setting up that foundational equation, x plus iy, all squared, equals a plus ib. Third, execute with clear working. This is where you expand the brackets to x squared minus y squared plus 2xyi. And then, you carefully equate the real parts to the real parts and the imaginary parts to the imaginary parts. You're building a pristine set of simultaneous equations here. Finally, verify results. Did you provide both the positive and the negative roots? Is it in the exact format they asked for? This pipeline right here, this is exactly how you build analytical depth over superficial breadth.
Moving on to part 2, the top 3 examiner warnings. Let's head into the autopsy portion of our explainer and diagnose exactly where candidates are dying on the exam paper straight from the principal examiner reports.
I want you to treat these 3 points as your ultimate rapid-fire survival checklist. Because examiners, they are actively hunting for specific terminology, proper headings, and context. Let's look at number 1. Answers are too vague. Now in high-level math, vague basically means skipping the algebraic derivation. If you jump from a complex equation straight to x equals 3 and y equals 4 without actually showing the simultaneous equations, yeah, that's vague. You're losing marks. Number 2, forgetting format and presentation. If the question explicitly asks for the answer in the exponential form re to the I theta, and you just leave it in the Cartesian form x plus iy, you've literally thrown away marks purely on presentation. And number 3, not specific to context. Let's say a root represents a physical length in a later part of a mechanics or geometry problem. In that context, a negative root might be completely invalid. You always have to filter your mathematical outputs through the lens of the given context. Let's look at this side by side. A flawed attempt, kind of like what we'd expect from our friend Sam, looks like absolute chaos. The calculations jump wildly from the initial problem right to a final complex number. The examiner literally cannot follow the logic, and as a result, it's just a sea of red pen marks. Now contrast that with a masterpiece. It's structured, it's logical, and it's context-specific. The real and imaginary components are separated cleanly, the simultaneous equations are clearly labeled, the format matches the command word perfectly. Top-scoring candidates understand a crucial secret. An advanced math exam is, actually, scratch that. It's essentially a communication exam. You are communicating your logical reasoning to the examiner step by step.
So you gotta ask yourself, why is this so difficult? Why do incredibly smart students just freeze up when they have to evaluate evidence and draw a conclusion in a high-pressure exam? Well, it all comes down to cognitive overload. When you stare at a massive, multi-part complex number problem, your brain tries to process the entire block of marble all at once. You panic, you lose track of time, and you completely fall out of your time management matrix. By the way, stop scrolling for a second. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Seriously, hit that button so you don't miss out on these strategies.
Which brings us to part 3, the method mark strategy. Listen closely, because this is your ultimate safety net, perfectly designed to protect your grade even when your final calculations go completely off the rails.
If you only take away one single thing from this entire explainer today, let it be this exact quote: "Showing your clear, procedural working is absolutely non-negotiable." The principal examiners are basically begging you to show your work. Let's play out a scenario. Say you're finding the square root of 5 plus 12i. You set up the equations beautifully. You write x squared minus y squared equals 5 and 2xy equals 12. Boom, you earn method marks. Then you substitute y equals 6 over x into the first equation. Boom, another method mark. But then, in a sheer moment of exam panic, you accidentally calculate 6 squared as 12 instead of 36. Ouch. Your final answer is completely destroyed. It's totally wrong. But because you laid out your logic like a master sculptor, because you showed every single step along the way, the examiner still awards you 4 out of the 5 available marks. Method marks are literally your insurance policy.
All right, Section 4. Deconstruct, solve, evaluate. Let's break down the exact 3-stage pipeline you need to navigate the chaos of an exam question and absolutely guarantee those method marks.
The top 1% of candidates use this exact pipeline to question their own assumptions and justify their math with hard evidence. Step 1. Deconstruct. You scan the data, highlight the command words, and extract the core mathematical values. Just get the raw materials. Step 2. Solve systematically. This is where you write down your formula, perform your substitutions, and calculate step by step. Remember, no jumping ahead. Keep that algebraic progression super clear and annotated. Step 3. Evaluate. Honestly, this is where most students completely drop the ball. Once you have an answer, just pause, look at it. Does it actually make logical sense? Like, if you just calculated a probability and it's 1.5, you know immediately you've messed up, because probability cannot exceed 1. If you're finding the square roots of a complex number, you must have 2 distinct roots. Check your reasonableness, justify your final formatting, and lock in those marks.
Now here's a quick mental cheat code to lock this framework into your brain forever. Try using a visual story method to encode these complex numbers. When you're dealing with them, picture the real component as the solid, heavy ground right beneath your feet, and the imaginary component as a tall ladder reaching straight up into the sky. When you set up those simultaneous equations, where the real parts equal the real parts and imaginary equals imaginary, visualize yourself physically separating the ground from the ladder into 2 distinct piles. By turning abstract algebra into a highly visual story, your brain retrieves the procedure so much faster under pressure, you won't freeze. You'll remember the sculptor, the ground, the ladder, and you'll know exactly what to do next.
Students who actually implement these mathematical strategies see massive improvements, for sure. Why? Because they stop acting like a hammer and they start acting like a sculptor. Watching this explainer is a great first step, but application is what physically rewires your brain. So drop a comment below with your target grade right now. And as you sit down to face your next massive block of mathematical data, are you just going to chip away blindly, or are you going to reveal the masterpiece hiding inside? Practice those past papers. And remember to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Catch you in the next one.